All right, let's see. Okay. All right, so first things first. Remember, this test tomorrow is just on the graphing portion of these two sections. So mostly just stuff from 7.1. So there's gonna be about 3 sections on this test. First one is matching. Okay. The definitions that you're gonna need to know for those are the definitions found for let's say I think it's about the first page and a half of those notes. So that means definition of an exponential function, definition of the natural base and the natural base exponential function, definition of exponential growth and decay, right? Those types of things, right? So should be like about the first page and a half of your notes. All the definitions there that'll comprise your matching section. Okay. Then you're going to have 2 additional sections. The next section is you're going to graph an exponential function, determine its domain and range, and determine if it shows exponential growth and decay, and explain why. And then when we get to the second section, it's going to be on function transformations, right? So graphing an exponential function, identifying its domain and range, then identifying the transformations on that function based off of another function, identifying its domain and range, identifying its transformations, and graphing that function. Okay, so that's pretty much going to comprise your whole test tomorrow. So without further delay, let's go ahead and let's get to this first section right here. Graph the function using an XY table, identify its domain and range, and determine if the function expresses exponential growth or decay. All right, so here's my function. F of x equals 2 to the x. So you're going to be given an XY chart to fill out, and then you're going to use that chart to graph the function. Okay, so when it comes to the XY chart, don't make it harder on yourself than it has to be. Use your calculator. Okay, and I will allow you to use decimals in your answers, rounded up to about 2 decimal places. Right. So if I go to my calculator and I type in, for example, 2 to the negative 2. All right. By the way, even if you don't use a calculator, you can still figure at least this problem out, right? So, because remember we did this a while back, negative exponents, right? So to make it positive, I bring the term down to the denominator of a fraction. So that'd be 2 to the negative 2 is 1 over 2 squared, which is 1/4. So that's 0.25. Okay. When x is negative 1, that's 0.5. Okay. The next 2 should be the easiest ones, right? Anything to the 0 power, right? And a basic exponential function with no transformations. Anything to the 0 power is 1. And then anything to the first power is itself. So 2 to the 0 is 1. 2 to the first power is 2. And then, of course, we know that 2 squared is 4. So we got all those points. We'll go ahead and graph it, right? So start here. This is 0, 1, 1, 2, 2, 4, about right here. And then negative 1, 1/2, negative 2, 1/4. So just kind of make your bet. So the graphs are going to be large enough to where it'll be easier for you to make a good estimate on where those decimal value points are. Okay. Now let's look at the domain and range. Okay. Let's start with the domain. What would the domain of this function be? You can either look at this here, or you can look at the graph to determine that. What's the domain of this function? Say that again. Good. All real numbers, right? Negative infinity, positive infinity, right? Looking at the rule of the function, just 2 to the x, right? There's no fractions in that. There's no even roots in that. So there's no reason for me to take out any x value. Okay. Even just looking at the graph, right? Left side goes all the way out to negative infinity. Right side goes all the way out to positive infinity if you're going from left to right. Okay. So domain is negative infinity, positive infinity. What about the range? What's the range of my function?
Everything above 0.
Right. So how about I write that using interval notation?
0, comma,
Yes, good. 0, comma, infinity. Remember, 0 is the horizontal asymptote, right? It's the line that a basic exponential function will never cross. Okay, and in this case, it's the x-axis, it's 0. Okay, now let's move on to the next part. Does this function show exponential growth or exponential decay? Why does it show growth? Good, excellent, yeah, because the base is greater than 1. So it shows growth because the base is greater than 1. What's the other case? What's the other case? So it shows growth if the base is greater than 1. When does it show decay? You got to be more specific than that. Between 0 and 1. You can't just say less than 1, because remember, the base of an exponential function cannot be negative, it cannot be 0, and it cannot be 1. So if you want to show exponential decay, then the base of your exponential function has to be between 0 and 1. Okay? Any questions on this section here before we move on to the next one? Okay. Now let's move on. We got some function transformations up here. All right, graph the parent function, identify the given transformations, and graph the transformed function. We're also going to look for its domain and range too. Okay? We'll start with e to the x. Again, don't make this harder on yourself. Use your calculator, right? Second, ln. That's your natural base exponential function, okay? So, and again, I'll allow you guys to use decimals. We'll round it to 2 decimal places. So when x is -2, y is 0.14. When x is -1, y is 0.37. All right, and of course, when x is 0, y is 1. When x is 1, y is 2.72. And when x is 2, y is 7.39. So let's go ahead and graph those. All right, so start here. 0, 1, 1, and then 2.72. We'll put that up here. 7.39. 2, 3, 4, 5, 6, 7. Put that almost right at the middle, right here. Okay, and then we'll work the other ones in. And again, the graph should be large enough for you to make your best estimate on where some of these decimal values fall. Okay, now I'm going to save you guys the trouble and tell you that e to the x and 2 to the x have the same domain and range. Notice that they look almost exactly alike. Okay. Again, for any basic exponential function where it's just the base to the power of x, no transformations whatsoever. The domain will always be all real numbers. The range will always be from 0 to infinity, okay, without including 0. But now let's look at the transform function, negative e to the x plus 2. Before we start graphing it, let's figure out what transformations we did to e to the x to get that other function. So I see 2 transformations up here on g of x. What are those 2 transformations? Okay, so we got a vertical shift up 2 units. Okay, what else?
X-axis reflection.
Good, x-axis reflection. Yes. So we have an x-axis reflection. I'll write that over here. X-axis reflection. And we have a vertical shift 2 units up. Okay. So let's make sure that we reflect that in that function. So again, you're going to be given the same x and y chart. Again, don't make it harder on yourself than it has to be. Use your calculator. negative e to the x plus 2. So that when x is negative 2, y is 1.86. When x is negative 1, y is 1.63. Now, when x is 0, now pay attention to this. E to the 0 is still 1, okay? But there is a negative sign in front of that e to the x. So negative e to the 0 is negative 1. But when I add that 2 at the end, it'll still give me 1. Okay? And then we do the other two. E to the 1 is negative 0.72. And then negative, when x is positive 2, y is negative 5.39. Okay. So now we'll go ahead and we will graph that function. Okay. So we'll start with, let's see, negative 2. That's 1.86. Put that about right here. Then a little bit less than that for negative 1. Okay, then we already have 0, 1 on here. And by the way, when you're working on these graphs, okay, make sure you differentiate both of those graphs, right? So maybe use like a dotted line for one, a solid line for another, like, or maybe do one in pencil and one in ink. Just make sure I can tell the difference between your two graphs. Okay, when x is 1, it says negative 0.72. We'll put that about right here. And then negative 5.39, so 1, 2, 3, 4, 5. We'll put that right here. And then we'll go ahead and make that graph. Mine's not perfect, but that's roughly about what that looks like. All right, now let's talk about domain and range. Okay. The transformations that we did, x-axis reflection and a vertical shift 2 units up. Did those transformations change the values of x? Did they affect the values of x? No. So is the domain going to be the same, or is it going to be different from e to the x? It's going to be the same. And you can even see it by looking at the graph too, right? Left side goes all the way out to negative infinity. Right side goes all the way out to positive infinity. Okay, now, those transformations that we did they affect the y values of the range? Yes. Can somebody tell me specifically which of the two transformations affected the range?
Reflection.
Not quite. Well, okay, you know what? No, I'll stop you right there. Technically, yes. Actually, that was a trick question. Forget I asked that question. Both transformations actually affected the range, right? Because if I reflect it, so e to the x has a range of 0 to infinity. When I make that x-axis reflection, it now the range now became negative infinity to 0. But what else happened? We shifted that graph 2 units up. So the horizontal asymptote originally was at 0. When I made that x-axis reflection, that did not change. The range may have changed, but the horizontal asymptote did not change. But when I shifted it 2 units up, I also shifted up my horizontal asymptote. All right, so now my range starts at negative infinity, but now instead of ending at 0, now it ends at 2. Okay, do you guys have